Okay, now that we've done the roughing and finishing of the part, facing, these two steps as we're cubing it, there's the facing, expand this, there's the roughing and finishing, then we can move on to doing these small radii. So there's a few ways, not radii, sorry, chamfers. A few ways we could do this. We could do this with the angled cutter. For me, I've found it to be more efficient to do things with the same sort of strategies. And in this case, I've found that just a ball end mill and a Z-level finish is the most effective way. I'll right click here, do a mill 3-axis, select all of my geometry. OK. Even though I'm doing these, I still want the cam system to know that there's geometry there so that it doesn't gouge into the part. And then I will determine which levels of the part get machined by either using my depths or by using later on in the advanced using check surfaces. So for machining strategy, I'm going to use a Z-level finish. And usually I start with a Z-level finish to do something like this just because it's the most quick to compute and the most reliable. I'll just key in an end mill here. So let's use a 16th with a 30 thousandths radius. Tool 4 is fine. Speeds and feeds will work just fine. Or if you wanted to change them, just click the check box and change them. Depth of cut, I found that somewhere between 1.5 and 3 thousandths is a pretty good step down for depth of cut in order to get a decent finish. Top of job and bottom of job are here. I'll pick the bottom of the job, which is really just that depth right there, and OK. I'll just give it a little bit past that point, so I'll put negative 0.04 just to make sure end mill goes all the way down. And depth of cut, I'm not leaving any there. If I want to compute a little faster, I can change that. And usually the follow method works fine. However, you want to spiral, which is lead in and lead out. And we'll put a smaller radius there. Tolerance, that's fine. And let's just go ahead and let this compute. See what it comes up with. Okay, so you can see, well, Z-level finish is okay, but it has the drawback that it likes to just do everything at that Z-level. So in advanced, maybe I could use a check surface, which we haven't covered yet. But there's another way that's pretty slick that we can just edit this. So I right click and I just edit toolpath. Right now I'm in this command to delete. So if I pick all the lines I don't wish to be in my actual cycle and apply that, okay, you can see that it deleted out those lines I didn't want. Right click, edit toolpath again. I'm still in the delete function. We can look at some of the other ones here. But for now, let's go with delete. Delete. Okay, pick something I didn't want to pick. That's okay. We'll just cancel. Go here. Edit the toolpath. And I'm just holding my left mouse. Gosh darn it, did it again. Cancel that one more time. If I looked at a named view, I can right click, go to a named view to make this a little easier. No. Edit toolpath. There we go. Select what I don't want and apply. Okay, that. I could get down to the nitty gritty and delete all these tiny lines out. There's no real reason for me to do that though. The outcome will be what I'm looking for. You see it also locks the toolpath, so even if I recompute it, it's not going to change until I would right click and unlock the toolpath, which you can lock any toolpath at any time. It just does it automatically when you edit it. So save that. Now all of these are posting out. If I didn't want to post something out, I could right click and choose post yes no, and you'll see when I do that what happens. There's a little X on it that says I'm not posting that out, but really I do want to post it out. And if I wasn't posting it out and I simulated, then it wouldn't show up in my simulation. But from here, we can go ahead and get a good idea of what it's going to do. For now, what I like to do is just turn the workpiece, just hide the workpiece. I like to not see my tool paths. I'll go ahead and run this. And we'll zoom up. You'll see that indeed our chamfers are on the part. Yet it's not gouging. We'd want to check that, make sure. If it shows up in your simulation, it's going to show up in your finished part. Looks like a good part. Again, in the cuming example, this would be extra stock left. Then I would flip it like so and hold it in the vise and then face off this backside and have a semi-finished part so I can just pop my holes in. That'll conclude this video. Next video up, I'll work on setting up multiple machine setups. So far we only have one. Actually, I have time for that yet, so let's just hit that one up. So I'll just collapse all that and I'll turn that off for now. Post yes, no, and if I right click on this, go to additional functions, I can insert a setup. The setup is still based off the stock that's here. Now there's two options, I guess, for doing multiple machine setups. I can create one in the same program, or I can go to milling job, go to cam defaults, and just make an entirely new job. Each job then is posted out individually, which means I get individual programs, which may actually be the better way to go in this case. So even though you saw there's a machine setup, let me just do both. You'll see why. So I'd have to come back here and just have it calculate my stock out again to get the raw extents of the part. Then I'll OK that and alter this machine setup too. And suppose I want it to be the back edge of the part one way or the other. You can see that it's giving me the extents based on the other extra 1/8 inch I added. So for now, I'm going to say that this backside of the part is where I want it. I'll go set my origin to there. Notice that my orientation is not correct. That's fine. I could do that in a few ways, but I found this to be the easiest. Just select which direction is the Y and then flip your Z. And we can flip the Y. And there we go. We got it how we want it. OK that. Again, we're going to save changes often. So now we have a new machine setup. So as far as drilling holes, I have to give BobCam credit here. BobCam does a pretty great job with holes. And as you know, holes get made often in machining. So as I select, just like most things, you right click on machine setup, come in here, I want to drill a hole. select that geometry. Now pick individual, you can do both, pick both hole sizes and go with it, but I don't think that's a great idea. You can see they've modeled some sort of tap in here. I'd have to consult the PDF. For now, I'm just going to make sure I get all of those hole surfaces that are there. And sometimes they're broke up into multiples, but this time one surface was it for that hole. I'll right click and OK. You can see I got a 1575, which tells me this might be a 632 tapped hole. But right now, in the strategy I'm in is just hole. Interestingly enough, though, this lends itself to something else. So let's finish this. And if I knew that we're a tapped hole, I could come in here and do a mill tap hole. Select geometry. We'll do that. We'll do that. Right click and OK that. Then from here, in general, sometimes they'll give you a basic idea, but if I know what thread it is, I can come down through here. Let's say it's a 632. OK that. But as I pick that geometry, it knows the depth from the model. This is giving me a strategy of center drilling, chamfering, and tapping. Well, I'm probably not going to chamfer this. I'm just going to do it with a spot drill. So I can always just, from any strategy, come in here and delete what I don't want. So I'm going to fly through this and just take the tools that they give me just so I can get this out in this 15 minutes I have. But you can see, the correct drill size was selected because I said it was a 632, so that's nice. And then I'm getting the 632 tap, and it's taking pitch times RPM and doing all those calculations for me. Now I'm probably not going to do it at 1700 inches a minute. It'd probably be more like, not inches per minute, sorry, 1700 RPMs, probably more like 200 RPM feed rate updates. And be careful when drilling because you can have multiple groups. You have to deal with multiple groups separately. Drilling, right? Here's the parameters for drilling. I want to peck it. And if I want to override this, I select it. And let's just say I want it to be 30. And I'll just apply parameters. So you can either give it what you want your center diameter or depth to be. So let's go with that. Compute. And then from that, I get my hole pattern. And that's ready to go. If I hit S on my keyboard, I can turn off the shading and I can see BobCat is taking and doing the drill tip calculation for you. Now, it's dependent on what I'm trusting. Its calculation is going to be the 118 degree calculation, which is the 0.3 times the drill diameter, which is in addition to the length. So for now, this is just a very basic, quick overview of drilling and doing multiple setups, but it should be a very good start.